In the video for figure 6.15, it was claimed that if we had had all of the possible samples of size 30 that we could take from a population of 600, the standard deviation of the means of those samples would be exactly equal to the standard deviation of the population divided by the square root of 30. It would be impossible to take all possible samples of size 30 from the population of 600, so it would be impossible to demonstrate directly the statement that the standard deviation of the mean values for the samples of size 30 would be exactly equal to the standard deviation of the population values divided by the square root of 30. But we can show that with the data shown here, which was seen earlier as a video with regard to figure 6.4. In that figure, we were showing that the average of the variances for all possible samples, 16 of those, was exactly equal to the variance of the population. Now we'll take one step further and show that the standard deviation of the means will be exactly the same as the standard deviation of the population values divided by the square root of the sample size, which in this case is 2. So the standard deviation of the means is equal to STDEV-P, since this is all possible samples, and turns out to be 1.274755. Now, if we find the standard deviation of the population, it is equal simply to the square root of the variance, which is 1.8. And now, if we get the standard error, it will be equal to the standard deviation divided by the square root of the sample size, and in this case we have samples of size 2. And when I hit enter, I see that this value and this value are exactly the same. So the point of this is that if we have the true standard deviation of the population, we can find the standard deviation of the means of all samples of any size by dividing the standard deviation of the population by the square root of the sample size. And in this case, we've divided it by the square root of 2.